And welcome back. In this video, we're going to explore the various parts of a lambda expression. So to begin, let's go ahead and look at a lambda expression from 10,000 feet. Let's look at its various fields and let's go ahead and color code them to make it very clear where one part of the lambda expression begins and then where the subsequent part begins thereafter. So just looking at this, we can see front and center here, a lambda expression. We can see that all lambda expressions are going to begin with a capture clause, also known as a lambda introducer. This will be followed by a parameter list, which is also known as a lambda declarator. Directly thereafter will be immutable specification, which essentially is going to have an implication for variables that are captured by value by our lambda expression. We'll get into what this means in good time. Thereafter, we're going to have a trailing return type. This will be optional. And thereafter, we'll actually have the lambda body, which will be the sequence of statements that are executed when this lambda expression is invoked. So I want to go ahead and consider the functions that you've seen to date. We said that they had some sort of return type. Let's go ahead and say bool. They had some sort of name. It's called identifier. They had a parameter list. And then, of course, there was the function body, which was the sequence of statements that was executed when this function was invoked. To go ahead and map the various components of the functions you're familiar with to the lambda expression that is perhaps new to you, let's go ahead and note that, well, our normal functions had a return type, and guess what? Our lambda function does too. Furthermore, we can see here that our function that we've been interacting with today had a parameter list. And guess what? The lambda function will too. Finally, the one, I guess, kind of outstanding point of similarity is that both also have bodies. We see the function body here that I just highlighted, and we can see the lambda body here as well. So with all of that in mind, that's kind of mapping what you know to maybe the unfamiliar. And then notice that there are some fields here that you haven't necessarily seen before. Well, maybe you have, but you haven't seen it before in this course. And perhaps the one that might be of interest is this capture clause. What's it all about? What are these square brackets for? How are they used? What are their implications? So the closure clause. A lambda can capture variables from the surrounding scope. We will see that this capture can proceed by value or by reference. Variables prefixed with the ampersand are captured by reference. Variables that are not prefixed with the ampersand are going to be captured by value. An empty capture clause means that the lambda does not receive any variables from the surrounding scope. And notice in the example, both on this slide and previous slide, we were dealing with an empty capture clause. If all you see is ampersand within the square brackets, that means all variables in the surrounding scope are essentially brought in to our lambda expression. So those you refer to within it can be considered as captured by reference. Give me 1 second. Likewise, if you were to see an equal sign, so just an equal sign between these square brackets, that means that all variables you refer to in the lambda body are captured by value. So you might notice I had to X some things out here. So I originally started trying to explain this by pass by value, but because it's something that you're familiar with. And then I kind of backtracked from that, and you can see a couple places where I forgot to update the slides because this is different from argument passing that you're familiar with. This is capturing. So I wanted to just make it clear and emphasize that some of the variables from the surrounding scope can be captured by reference. Others can be captured by value. And this is going to be different than seeing, say, something within a parameter list which is like could be passed by value or passed by reference. So in the next video, we will spend some time with the closure clause and discuss the implications. And we'll even give a couple of examples to better familiarize you with the closure clause than what we're doing in this video here. After the closure clause, we have the parameter list. The semantics of the parameter list here is mostly identical to that of the functions you're already familiar with. Essentially, what we're going to do is specify the types and identifiers for your lambda's parameters as you would have done for a function. The immutable specification. By default, the parameters storing captured objects captured by value to your lambda function are implemented as immutable data members. And we'll see an actual kind of how the compiler is going to take your lambda expression. It's going to go ahead and convert it into a closure class, which will have the call operator defined for it. And when we get into that, we'll see the implications of this mutable specification during that translation. But we can kind of associate the closure clause with initialization of a function object, perhaps. And this mutable specification is going to dictate whether the kind of data members that would have presented in a function object, whether they would be constant, so read only, or mutable in the sense that you could both read and write to them. So this, again, it will really make sense when you see a lambda expression translated into a closure class. This will come together. But right now, understand that this mutable specification is somehow related to the closure clause, and we'll show you exactly how here in a forthcoming video. But to kind of continue this on, by writing mutable, the parameters storing captured objects captured by value to your lambda function will become mutable data members, and you will be able to assign to them within the body of your lambda expression. The return type. So the return type of a lambda expression is going to be automatically deduced by the compiler. Therefore, frequently this trailing return type is left out of our lambda expressions. When we would like to explicitly specify the return type of our lambda expression, we can go ahead and use a trailing return type as shown above. So in this example here, that type, so the return type, is the Boolean type. Now finally, the lambda body. The lambda body can contain anything that the body of an ordinary function could contain. And it also affords access to these kinds of variables. Any variables captured by value or by reference, the parameters to our lambda expression, as well as any class data members, provided this lambda function was declared inside a class somewhere, as well as variables with static storage, such as the global variables within maybe some sort of application. So with that, let's go ahead and move on to how lambda expressions kind of serve as syntactic sugar for function objects. And in this process, I think you'll become more familiar with the different parts of a lambda expression.